Let's think back to a concept that we learned several videos ago. We know that this is an algebraic expression, but we will oftentimes be in a situation where an expression is accompanied by an equal sign and then another expression. Let's say 5. When we have an expression equal to another expression, we no longer call this line an expression. Instead, we call it an equation. So let's think about what this equation right here really means. It says a number plus 2 equals 5. Okay, now how would we be able to find the value of x? Well, one way, and let me just preface this by saying that this is not a great way to do things, is to simply substitute x with a bunch of different numbers until we happen to arrive upon a number that satisfies the equation. We call this method a trial and error method. Alright, so let's try this method out. Let's start with 0. 0 plus 2 does not equal 5. So, x is definitely not 0. Let's try 1. And 3 is not equal to 5, so x is not 1. So let's move on to some more guessing. We try 2. 2 plus 2 does not equal 5, so x isn't 2. Now let's try 3. Well, 3 plus 2 does equal 5, so it seems like we got our answer. X equals 3. Now, although we did arrive upon an answer, this trial and error method took us a very long time. Our objective in this video is to learn how to get the value of a variable within an equation without using this trial and error method. Once we learn how to solve an equation properly, everything is going to become much more efficient. Good. So first of all, you might already know this, but whenever you have an equation, you can do any operation you want onto any side of the equation, as long as you're doing the same operation to the opposite side of the equation. So, as an example here, if I were to subtract the left side by 2, then I would also have to subtract the right side by 2. Simplifying the left side would get us x, and the right side would be 3. So x equals 3. Alright, it looks like subtracting both sides of the equation by 2 happened to give us the answer, and we'll go over how we got to this point, but before we do so, let's talk about the idea of performing equal operations to both sides of an equation. The idea of an equation is simple. The left side is equal to the right side. One easy way to visualize the idea of an equation is to think about a balancing scale. Of course, a scale can only be balanced when the weight on the left side is equal to the weight on the right side, hence the comparison. And what happens if we take a certain amount of weight away from the left side? Well, now the right side would be heavier, and so the scale wouldn't be balanced anymore. In order to keep the balance, we would have to take the same amount of weight off from the right side. Similarly, if I add a certain amount of weight to one side of the scale, I would have to add that same amount of weight on the other side in order to keep that scale balanced, or shall I say, equal. And it becomes even more obvious when we think about everything we just said about the scale in terms of a simple equation. For example, 5 equals 5. So this is like a scale where there's 5 blocks on one side and 5 blocks on the other side. Naturally, if we can assume that the blocks weigh the same, the scale would be balanced. Now in this equation that we have written over here, the equal sign is alluding to the balance, or more accurately, the equivalence of the two numbers. And it's pretty clear that this statement is obviously true. After all, 5 does equal 5. But what would happen if I subtract the left side by 1? Well, I would get 4 on the left side, and does 4 equal 5? Nope. As a matter of fact, the only way I can continue to claim that the left side is equal to the right side would be to also subtract the right side by 1. And now we would end up with 4 equals 4. And of course, this is true. We got here by doing the same operations on both sides of the equation. Great. And this is exactly what we did with our simple equation in the beginning of the video. We started with one equation, which was x plus 2 equals 5. We decided to subtract both sides by 2 and ended with another equation, x equals 3. So, since the question originally asked us to find the value of x, we can see that we have indeed found the value of x to be equal to 3. So by now, we understand what an equation is and why we need to perform the same operations on both sides of the equation. Now all that's left is for us to know exactly what types of operations need to be performed in order for us to arrive upon the answer consistently. In our previous example, subtracting by 2 was the correct operation which led us to identify the value of x. Well, the idea is for us to end with our variable isolated on one side. If you go back to our previous example, notice that our answer had x and only x on the left side. So how do we isolate x? We do this by using inverse operations, or shall I say the opposite operations that help to undo the manipulation that has already happened to x. So the way to undo addition is to subtract and vice versa. As well, the way to undo multiplication is to divide, and vice versa. In our first example, we saw our variable being added by 2, and so we subtracted our variable by the same number. This helped us to isolate the variable easily. Awesome. So let's try another example. How can we solve an equation that looks like this? Well, we see that x is being subtracted by 7. And remember, we can undo this subtraction of 7 by doing the inverse operation of subtraction, which is addition. So we add 7, and of course, we also add the right side by 7 in order to keep the equation true. Our final answer is x equals 9. And if we ever want to double check to see if we correctly found the value of the variable in this equation, just substitute your answer in the equation to see if you arrive upon a true statement. For example, when we substitute our answer 9 for x, we get 9 minus 7 equals 2, which is 2 equals 2. This is a true statement, and thus we know that our answer is correct. Pretty easy, right? Now let's try another example with multiplication in there. 3k equals 12. In this equation, our variable is k, and it is being multiplied by 3. What's the inverse operation of multiplication? That's right, it's division. So we divide both sides by 3, and we get k equals 4. Once again, if you think that you might have gotten something wrong, just do some scratch work on the side and plug in your answer to double check for correctness. And we get 3 times 4 equals 12. When we simplify the left side, we get 12 equals 12. Awesome, so we know that k equals 4 is a correct final answer. Alright, now in this final example of ours, our variable is being divided by 6. To solve this equation, all we would have to do is to multiply both sides by 6. And we would get p equals 6. And since 6 over 6 is equal to 1, we know that we got the right answer. Okay, so we learned quite a bit in this video. We learned the concept of an equation. the importance of performing the same operations to both sides of an equation in order to keep the equality true. And we learned the importance of using inverse operations to isolate the variable and eventually find the answer. In our next lesson, we're going to learn about how to approach a multiple-step equation, where we have more than one operation to deal with. So we invite you to join with us in our next video.